Hi, myself Kanati Gopal and my teammates are Satvik Reddy Karkala and Relax Reddy Tarbhai. We are presenting in the topic of deep learning for information retrieval. Let's dive into let's dive into introduction to information retrieval. Information retrieval is the process of searching and retrieving relevant data from large collections of documents, databases, or web pages. In response to the user query, the main goal of our information retrieval is to provide users with the most relevant documents or data points based on the query, which is typically expressed in the form of text. IR systems use a variety of techniques to index, search, and rank documents to ensure that the results meet the user's needs. For example, when the user enters a query into a search engine like Google, the AI system shifts through billion of web pages and returns the most relevant results based on the various factors such as relevance, recency, and authority. Common applications of information retrieval include search engines, document retrieval systems for legal or academic research, and recommendation systems which suggest products, movies, or content based on user preferences and past behaviors. Traditional IR systems often rely on keyword-based search techniques where the system matches the query's keywords to those of the indexed documents. While this approach works well for many applications, it has several limitations. Keyword-based systems may not capture the full context of the query or the semantic meaning behind the terms, leading to irrelevant or incomplete results. Additionally, they may struggle with synonymy, like different words with same meanings, and polysemy, same word with different meanings, as they are purely based on the presence or absence of the keywords. Uh, Next slide, please. Let's see the role of deep learning is in information retrieval. Why the deep learning is very important for the information retrieval. Deep learning has significantly transformed the field of information retrieval by enhancing the ability to understand and progress large volumes of unstructured data, text data. Traditionally, information retrieval models such as the vector space and TF-IDF primarily relied on matching extract keywords in the query in the document, which worked well for similar task search but struggled with the more complex queries. These methods typically treated each word independently and did not account for the semantic meaning or context in which the words were used. On the other hand, deep learning models, particularly those based on the neural networks, have the ability to capture the inaccurate patterns in text data by learning from vast amounts of information. Through techniques such as the word embeddings, for example, we can take the word to vector glow or conventional models. Conventional models. Deep learning can progress words in relation to the surrounding content, allowing for a much richer understanding of language. One of the major advantages of deep learning in information retrieval is its ability to provide contextual understanding, allowing the system to grasp the nuisance, the multiple meanings of words based on their usage. For example, deep learning models can differentiate between the meaning of bank in the context of river bank versus finance bank, something that traditional models could not easily do. Additionally, deep learning improves the concept of semantic search, where documents that are semantically similar can be identified. Next slide, please. Let's see the deep learning models of information retrieval. There are different types of models in deep learning for information retrieval, such as convolutional neural networks, originally developed for image recognition tasks, have been successfully adapted for text-based tasks in natural language processing, including those in information retrieval. In information retrieval, convolutional neural networks are used to identify local patterns within text data, such as specific sequences of words, which can be crucial for tasks like sentence classification and document retrieval. For instance, convolutional neural networks can be employed for document classification, where the model learns to categorize documents based on their context. For example, classifying articles into topics like sports, politics, and technology. Additionally, convolutional neural networks are efficient in query document matching, helping to determine the relevance of the document in response to the given search query. By applying the convolutional layers, CNN convolutional neural networks can capture important features such as n-grams or phrases that are indication of relevance, making them useful for improving the accuracy of document retrieval systems. Next slide, please. Let's see the recurrent neural networks. It is another type of neural networks designed to process sequential data, making it particularly well suited for tasks involving time series data, text, or any type of input where the order of the data is important. Unlike traditional feed-forward neural networks, which treat each input independently, recurrent neural networks maintain a hidden state that carries information from previous time steps, enabling them to remember and leverage past inputs when processing new data. Next slide, please. Transformers. Let's the transformers, EBRT and GPT are the models in the Transformers. Transformers has fundamentally changed the landscape of natural language processing and information retrieval by introducing the self-attention mechanisms that allows models to efficiently understand context across long sequences of text, unlike previous models that process the text sequentially. Transformers can simultaneously consider all words in the sentence, capturing relationships between words regardless of their position in the text. Key models built in the transformer architecture include EBRT like bidirectional encoder representations from transformers, which generates contextual word embeddings by considering both the left and right content of each word, and GPT generative pre-trained transformer, on the other hand, focuses on text generation and semantic search. Next will be continued by Satvik Reddy Karkala.
Next slide, please. Yeah. Now let's see the applications of deep learning in information retrieval. Deep learning enhances search engines by improving result relevance through semantic research, ranking algorithms, and document retrieval techniques. Models like BERT and DPR enable search engines to understand user intent, match queries with semantically relevant documents, and rank them contextually rather than relying solely on keyword matching. Neural ranking models refine search results while query expansion techniques improve search accuracy by rephrasing or adding synonyms. Additionally, deep learning powers personalized search by analyzing user behavior and preferences. These advancements modern search engines more intuitive, accurate, and context. Next slide, please. Deep learning significantly enhances question answering systems by enabling them to retrieve precise answers from large text corpora based on user queries. BERT-based models improve accuracy by understanding the context of questions, allowing for better extraction of relevant information compared to traditional information retrieval methods. Additionally, deep learning powers recommendation systems through content-based filtering, which suggests items based on a user's past activities, and collaborative filtering, which analyzes user interactions to predict future preferences. These advancements make QA and recommendation systems more initiative. Next slide, please. Now let's see how deep learning improves information retrieval. Uh, Deep learning has transformed information retrieval by making search systems more intelligent, efficient, and context-aware. Unlike traditional IR methods that relied on exact keyword matching, deep learning enables semantic understanding using neural language models like BERT, GPT, and T5. Word embeddings capture word meanings, while transformers models improve contextual understanding and intent recognition. Additionally, neural ranking models like called BERT and mono-BERT refined search rankings, leading to more accurate and relevant results, text, images, and videos. Next slide, please. Yeah. Now let's see personalized search and recommendation systems. Deep learning has revolutionized personalized search and recommendation systems by shifting from a one-size-fits-all approach to dynamically predicting user preferences based on past searches and behavior. Techniques like collaborative filtering, matrix factorization, autoencoders learn user interests, while RNNs and LSTMs and transformer-based ranking models capture behavioral patterns to refine recommendations. In visual search and multimodal retrieval, deep, deep learning replaces traditional metadata-based indexing with CNNs, vision transformers, and multimodal models like CLIP and Align, enabling more accurate image and video. These advancements make search and recommendations more personalized, initiative, and efficient across multiple data types. Next slide, please. Now let's see speech and voice search. Deep learning has advanced speech and voice search by enabling voice-based queries all through automatic speech recognition models like deep speech and which convert speech to text, and transformer-based NLP models that extract meaning from spoken input. Multimodal learning models like Whisper AI and Speech BERT further enhance search by integrating text, speech, and video understanding. Additionally, deep learning has improved sentiment-aware and opinion-based search by not only retrieving reviews but also analyzing sentiment using techniques like recurrent neural networks, and sentiment-aware transformers. Uh, Aspect-based sentiment analysis further refines this by identifying sentiment related to specific product features, making search results more insightful and user-centric. The next slide will be continued by my friend Relax.
Thank you, Satvik. Deep learning libraries for information retrieval. So we have some libraries in NLP used for query understanding, test ranking, and document similarity. Huge face transformers provides retained models like BRT, T5, GPT, Bird, and Colbert used for query expansion, ranking, and passage retrieval in IR. Example, BRT-based ranking models improve document retrieval relevance. NLTK, classical NLP tool for text processing, tokenization, streaming, and stop word removal, used for basic text normalization and query pre-processing before deep learning models are applied. SPECI, it's a NLP library dependency prioritizing, named entity recognition, and limitization. Also used for query intent detection and entity-based retrieval system. Genism, it's a library for topic modeling and vector space representations like word to vector, document to vector, and LDA, used for semantic search and document clustering in NLP. And there are the neural ranking search frameworks which can be used for ranking and retrieval. So Pasrini
a Python wrapper for answering and supporting BM25 and neural ranking models used in dense retrieval for BERT-based ranking and hybrid search. So Madzo open source framework for neural ranking models such as deep structured semantic model, deep relevance matching model, conventional kernel-based neural ranking model useful for learning to rank tasks in search engines. Collaborate contextualized late interaction but efficient for system performance, fast down retrieval without full cross-encoder computation, efficient for base retrieval, and used in large-scale search like Wikipedia, academic papers, and enterprise search. And we also have vector search similarity matching. These libraries are used for semantic search, vector-based retrieval, and approximate nearest neighbor search. So we have like Facebook AI similarity search, scalable vectors as library for fast similarity search using embedding, support GPU acceleration for high-speed nearest neighbor search, used for semantic search, image retrieval, and document ranking. Anonymy, used for efficient memory map to vector search library for Spotify, suitable for recommendation systems and fast lookup for high dimensional vectors. Scalable nearest neighbor for Google's vector search framework, optimized for efficient ANN search. So we also have deep speech, open source speech to text model for voice search application used in spoken query retrieval. And we also have Whisper, an open AI multi-signal automatic speech recognition system, enables cross illegal voice-based information retrieval. And we also have some challenges of deep learning for AI. So we have some like data dependency. Deep learning models requires large amounts of high quality training data to be effective. Many specified domains like medical, legal, financial, it's a lack of sufficient labeled data. Collecting and annotating data for IR models is costly and time consuming. So the solution is for researchers are exploring self-supervised learning and data augmentation techniques to reduce dependency on labeled datasets. It also have high computational cost. Training fine deep learning models requires powerful GPUs. High costs limit accessibility for small organizations and researchers. Real-time applications of search engines, voice assistants require efficient inference, but deep models can be slow. So we have some solutions of comparison techniques, pruning, quantization, knowledge distillation help reduce their overhead. And we also have interpretability and expandability. Many deep learning models, especially transforms, black box models, meaning the decision maker processing is not transparent. Lack of interpretability raises concern in fairness, bias, and accountability for IR systems. So we have some solutions of shapy additive explanations are being used to make deep IR models for more interpretable. So the future of deep learning in IR comes upon with multimodal information retrieval. Current IR model mostly focus upon text-based search, but future IR system will integrate text, image, audios, and videos. Example, Nike running shoes could return text articles, product image, video reviews, and voice descriptions. Some of the technologies like vision transformers, underrated images of virtual search, multimodal learning, and speech-based retrieval enables voice-based search. So we also have cross-enable information retrieval. Deep learning models will enable cross-enable search, allowing users to retrieve documents without requiring translations. Example, a user can search Spanish in English or other documents. Some of the key technologies like BERT, XLMR. So we also have personalization and contextualized research. Future engines will adapt user behavior and preference in real time. Instead of generic results, AR models will rank and retrieve documents based on past search, interest, and contextual information. Example, two users search for Java might get different results, one off from programming language, one off from island in Indonesia. Some of the key technologies of neural matrix factorization, transform-based personalized ranking models. So I'm concluding that deep learning has significantly improved research relevance, query understanding, document ranking, IR systems. Models like BERT, GPT transformers have enabled semantic search, understand context synonyms and intent rather than relaying keywords. Some of the challenges like computational cost, data dependency, lack of interpretability. So future of IR lies in search, AI-driven personalization, make IR smarter, faster, more user-centric. So thanks for the opportunity.